Okay, I think I'll go ahead and get started here on the next topic area, manufacturing process innovation. Thanks for everyone joining the call live and those joining after the fact via webinar. My name is David Snowberg. Been working in the wind energy industry for about 25 years. The last half of that here at NREL, and prior to that worked at small wind manufacturers and OEMs doing consulting for distributed wind. So this topic area is manufacturing process innovation. So the scope of this is related to manufacturing, the first word here. So that's an important distinction here. This isn't and it's also an upgrade. So what's implied there is that you are manufacturing products at this time, or at the time that you're proposing putting together your proposal for this topic area. If you're at the prototype development stage, manufacturing process innovation is probably not the right step at that time. This is for making improvements to manufacturing, the lower costs, to build on what you already are doing with manufacturing your product. Second bullet there about emphasizing a disciplined engineering development process. So with manufacturing upgrades, they should be relatively low risk. I mean, there's going to be some risk in anything that's done, but it shouldn't be too out there in terms of what would be an upgrade to a manufacturing process. And everything that's done applicable to this topic area should be consistent with certification. Certification isn't the primary goal for this, it's the manufacturing improvement, but it should be consistent with what's already certified or be helping to enable certification going forward. So for this topic area, the applicant would select a baseline wind turbine or component. So the wind turbine could be the full manufacturing of that system, or it could be a component such as a wind blade, making an improvement to that as far as how that's manufactured. Let's see. So related to wind blade manufacturing improvement, tooling could be part of that, and tooling is a big part of any part of manufacturing. So tooling upgrades could be part of the improvement. There could be other equipment that's specified and developed through this type of topic area. So really a lot of possibilities, but the end result and how it should be measured is lowering the levelized cost of energy over the baseline. So that's certainly how things are measured in terms of, is it worthwhile making this investment in this tooling? Is it worthwhile to make investments in other types of manufacturing process improvements? You know, take a look at where you're at right now for cost and what would be the benefit to make these investments. So the tasks here are very similar to other topic areas. Task 4.1 is the summary of work effort. This is mostly, if not entirely, publicly information that will become publicly available. So it should be that level of information, and it's usually it'll be the first deliverable, and usually in the first month. The next task is, establishing where you're at with your current manufacturing process. So clearly describing your current state of the manufacturing, including production volume, data, costs. So what should be implied there explicitly is that you are manufacturing going into this. You're not at a prototype level and need to figure out how to manufacture it. So this is making improvements to an existing manufacturing process. The next task 4.3 will be the implementation plan. So this is what you're planning to do. What is the process that you're improving? What's your plan to get to that improvement? Important here with manufacturing is details about quality control, quality assurance. So that should be part of your manufacturing operations or something that you're working towards improving through this type of upgrade. And then task 4.4 would be the implementation of the manufacturing upgrades. So providing evidence that you've made the improvements that were proposed, that you've achieved the quality control, the production volume, cost reduction, and any other relevant parameters. And important with cost, if reliability went down, you have not made it a cost improvement. So there's definitely a connection between cost and quality and reliability that needs to be considered throughout any type of improvement. And then the final task would be the realized levelized cost of energy improvement. So what have you actually accomplished, and reporting on that as the last task. So here would be the deliverables associated with those tasks. So first one there again is typically done in the first month after the subcontract is executed, and that's as mentioned there, void of business sensitive information, because NREL and DOE will publicize that for the benefit of everyone. And the second one being the letter report describing the current state of manufacturing and requirements, specifications, where things are at now with your manufacturing. That's typically 2 months after the date of subcontract execution. Third one there, task 4.3 would be 3 months after, and that's the implementation plan. So what's your plan to achieve what was proposed? And then, as is the case with several of these subcontract deliverable schedules, there's a gap as the work is being done, as the manufacturing improvements are being made, possibly tooling is being specified and procured. That can take a bit of time. So the next deliverable, it would be the final report that's documenting the upgrade and the implementation of the work defined in that plan from task 4.3. And that would be 19 months after that. And the next one, task 4.5, is what is the levelized cost of energy, the LCOE improvements that have been implemented as a result of this work. And the last one there, quarterly reports. So those are going to be on all CIP subcontracts, a report on what was the work that was accomplished, what were any issues that were encountered, what was what are the plans going forward. So that's going to be common for all of these. And with these deliverables, as was also mentioned in prior topic areas, there can be additional deliverables added. So it's not, this is the main framework for this topic area, but it's not meant to be an exhaustive list of what would be the deliverables for a subcontract. So scoring criteria. I think with any proposal, if someone's writing a proposal, it doesn't matter if it's CIP or any other type of solicitation, paying attention to the scoring criteria when it's provided is a very important step. Not just paying attention to it, but understanding it and writing the proposal in a way that addresses the scoring criteria, because when reviewers review proposals, this is how they are scored. So it's can't emphasize that enough in terms of writing a proposal. Pay attention to the scoring criteria and address and maybe potentially over address these areas. So first one here, 25% is demonstrating that the proposed manufacturing innovation is beneficial and the successful improvement in the market position or entry into the market and consistent with certification and listing of the turbine. So there's a lot there. Some of the sub points there is documenting your turbine specifications. So at this step, you should have clear turbine specifications that you're working for and working to improve, potentially through the manufacturing process upgrade. Next point there would be the description of the proposed manufacturing process innovation, identifying technical enhancements or advancements. So, make it clear. What are you improving? Why is that important to do? What is going to be the end result of doing that? Next subtopic there would be analysis of showing how this is going to affect turbine sales. So certainly if cost goes down, there's often a correlation there with more sales, but make that clear if that's what you're anticipating through this improvement. And provide a benchmark. So that may or may not be your baseline turbine. It could be competition, and wind doesn't necessarily have to be wind energy, but provide some level of benchmark that you're assessing. All right, what else here? So we have description of the work done to date in preparation for the proposed upgrade. So that would be any background work that's been done, identifying that this type of improvement has the best impact. You've considered X, Y, and Z options, but of those, this is the one that has the best return on investment. So whatever background you've done, that would be useful information to put in your proposal. Description of the company's manufacturing quality control protocols. So that would be if you're, for example, ISO 9000 certification for your manufacturing or some other type of level of quality processes. That's where describe where you're at. That will be helpful for reviewers to understand what your quality protocols are. Last two items there is estimating what your installations will be based on this implementation. So what's the impact of doing this work, and how is that going to affect U.S. Deployments in the U.S. as well as exported units? So that's important as well. We're making product here in the United States and sending them overseas. That's a benefit all around. So make those estimates realistic and back them up. Don't just make wild claims that sound good but don't have anything to back it up. The next scoring criteria 2 here, and this is the largest one for this topic area, 30%, is demonstrating evidence that the investment in the process innovation will contribute to a reduction in the levelized cost of energy. So here again, that's if you're going to make an investment in tooling, improving a manufacturing process, then there should be a very clear benefit when it comes to lowering the cost of the product that you're manufacturing. And so that can be assessed as quantifying that cost for the initial system as well as the overall life of the system. So those type of improvements can be measured in different ways. And part of that would be developing the levelized cost of energy worksheet that is has been part of solicitations in the past. And last one there is quite important. Innovation is clear technical merit. So make it clear that this improvement that you're proposing has technical merit, and here's why. So that's scoring criteria 2. Scoring criteria 3 is about the development plan. So part of your proposal would be the development plan for the manufacturing upgrade. And it needs to be consistent with certification and listing. So if it's making some changes, possibly some components will need to be reassessed by a certifying body. So make it clear what that might be. And also US market focused is important for these improvements. So this one is at 20%. So so it needs to be consistent with certification or listing. And so just describe how that is the case, and how you have sufficient resources to do that, to do the work. Let's see, documentation of the tooling or manufacturing capability development cost. That's going to be important. So if you're proposing to develop some type of injection molded tooling or some type of blade mold, whatever it may be, what is, don't just estimate the cost is going to be so however many $100,000. Have something to back that up with some quotes, some tangible documents that make it clear that if this subcontract was awarded, that it won't be a surprise. Well, it's not actually 250,000. It's $1 million. So do your homework going into this type of proposal. And direct impact of the U.S. market. So that should be clear in this type of work that the benefit is here in the United States. So when it comes to jobs, product deployment, domestic manufacturing, all of that is part of what should be the measurable benefit from this type of work. And last but not least, for the scoring criteria is the team, and this is at 25%. So as part of the proposal, document the qualifications of the project team and with respect to their responsibilities on the project. It helps to have include the right team for what you're proposing to do. So if you're proposing to make some custom tooling, having people with experience in developing that type of tooling is pretty critical to the success of that development. So include the resumes of your team. Also include letters of participation, letters of intent, letters of commitment from your team. Make sure your team knows they're on the team. Don't just list the top names in the distributed wind world and they don't know about that. That's not a good thing. So make sure you have a good team together and that you're ready to work on this project if awarded. So for historical funding in this topic area, the maximum amount has been $500,000. The minimum price participation, 50%. And just to clarify what that would be, if you were to request an award of $500,000, the price participation is based on the total project cost. So that would mean you would need to put in $500,000 of price participation to receive an award of $500,000. So, and that's a minimum. So you certainly can put in $1 million for that type of work. And 50% is more than other topic areas. Some are 20% and there's another one that is 50%, I believe. But one reason that's 50% is if there's a tooling investment, if there's equipment that needs to be procured, that's likely going to be to the benefit of the applicant to have that as part of their price participation, so that at the end of the subcontract, it's clearly the property of the subcontractor and not the owners, and it's not Department of Energy property. So that's one reason. So you want to, when you're putting together this type of proposal, consider property ownership and assuming you want to keep the property, which is likely the case for any type of manufacturing process innovation, you'll want to make sure that you're using your dollars to pay for the equipment, and the right way to use the funding for this award would be for the labor, for the development, for the implementation and validation of it. So here's I have two examples. Recently, Matrix Limited was awarded a subcontract in manufacturing this year, 2021. And this build on prior work from a previous CIP, developing a 25 kilowatt single phase inverter. And the goal of this subcontract was to bring Intergrid's innovative 25 kilowatt wind inverter to full commercial production. And the subcontract or this work is unique in that it meets the needs of several OEMs, several US distributed wind turbine manufacturers. So it's a way of bringing certified electronic solutions to several wind OEMs. So it's a win-win for many different groups. So this, and it brings the Intergrid inverter to full manufacturing readiness. So this is one example of a manufacturing CIP that was recently awarded. Another one from a few years back was injection mold tooling for the Pika T701 blade. So what's shown here in this picture is a is the tooling for that blade. With this type of tooling, it's pretty expensive with the steel to start with, and then the machining of it, and all the work to assemble the tooling of this size is many hundreds of thousands of dollars. So it's something that could be potentially to consider for future applicants, tooling upgrades like this. And with that, I'm at the end of this slide deck, and we'll look for any questions. Let's see.
Dave, Robert
Yeah.
asked one in the chat. Is it true that proposals can add deliverables, or are they added during contract negotiations?
I'm gonna defer that to you, Brent, or Ian, to address that.
Actually, my question is it still true that
Okay.
proposals can add deliverables, or that they can be added during contract negotiations? Because in the past, NREL's done it both ways. I mean, they've allowed both options.
Yeah, so the answer
Thanks,
is
Robert.
all of the above. So as part of the application, we do one of the attachments is a deliverable schedule. So you can go in there and add deliverables there. That's the best way to do it because you're upfront about that payment schedule. But that can be adjusted, is adjusted up until the point where the contract is signed, and then even after the contract is signed. But up to the point where the contract is signed, you have the opportunity during that negotiation to both propose new or different deliverables, but then also change the amounts, just so long as the total amount doesn't change significantly.
Thanks.
You can do it either place. But I would encourage you to do it in your proposal.
Great, thanks, Ian, for the answer there.
Mhm.
I don't see any, looks like the questions in the chat have been addressed. Brent, thanks. Mike Berge, looks like you have your hand up, a question. Go ahead, Mike, if you want to ask your question now.
So let's say you wanted to do a new way of making the same blade. So the blade shape doesn't change, but the way in which it's manufactured is. So is that best? Can you do that in manufacturing, or does that need to go back to component? Because you're going to change, say, from infusion molded to a heated press compression mold.
So is the blade itself,
Is
how much of
the shape is the same, but the way
shape's the same?
but the skin and core would be different because the manufacturing process is different.
Yeah, I mean, I would think that would certainly fall under a manufacturing improvement. Yeah, I mean, potentially it could be a component innovation as well if you're really changing the structure of the blade, even though the shape is the same. If the structure is changing, I guess maybe that's my question. Are you changing the structure of the blade, or are you maintaining the structure and just changing how you manufacture it?
Well, inherently the structure changes because if you've got a lower strength skin, you've got to do more internal work. Let me put it another way. If you did that and you went through the component and just made sure that the tooling, which is bound to be more, be the major expense, that your cost share is enough to cover the cost of that tooling. That would also work. And of course it would have the advantage of I was going to say the 20% cost share would be advantageous, but you're going to run up a high contribution due to the expense of tooling.
Yeah,
So I guess I'd wonder what's the work you're doing? Is the work more tooling investment, or is the work you're doing more developing the new structure that's compatible with the new?
Well, you've got to
manufacturing?
do the new structure to allow you to do the lower cost manufacturing technique. But, all of that stuff generally requires expensive tooling,
yeah.
quite expensive tooling.
So I think following on Dave's thought here, I mean, my guess would be, I think you could probably do it either way, but if the majority of the expenses are going to be on the tooling and manufacturing process, then it's manufacturing. And if it's more on the design of the new blade to allow for the new tooling or for the new manufacturing process, then you would do it as a component improvement.
Okay. Yeah, I can see it both ways. So that's, thanks for.
Yeah, and so I would say go and then look. And so if the
Yeah.
majority of the cost is on the tooling, then even if you did it as a component innovation, you would probably, I mean, you have the 80% cost share, but you're probably only asking for a bit of money for the engineering and a very little money because you have to pay for the tooling, or you want to pay for the tooling so that we don't take it away from you after the end of the contract.
Right.
So,
okay. Thanks.
Yep.
Yep.
But
Yeah.
but I think that would be a perfect thing under the manufacturing, under either one of those. That's the kind of stuff that we'd be looking for.
Great, thanks, Mike, for your question. Any other questions?
Davis, Brent, I'm just, after seeing the picture of the pica tooling and knowing there's a 50% cost share, am I assuming right that pica is continuing to own that tooling?
Or
is that complicated?
yeah, I don't know.
They do,
Okay,
because I was around when that happened, so.
right. All right, cool. Yeah, good to know.
Yeah, and it resulted in a 75% reduction in part cost.
Yeah, I bet.
And allowed them to go to higher rate manufacturing. Not that that helped very much.
That's another story.
Yeah, exactly.
This is Kevin from Wyco Wind and Solar. I've been on this video for the last several days, actually every day. And I guess the question that I have is, being pica energy came up, where does that technology stand now? I mean, obviously NREL was a participant in it, and obviously, my interest here as an installer, solar wind company is, presently we got 250, 300 sky streams in the field, and it seems like the industry has abandoned them. And those are my customers. And if we're going to maintain, if you will, good stead with the public, I think there's something to be said for a system that has put out 8,000, 9,000 units, and now you can't even get a brush assembly. I mean, let alone get any kind of other support. I mean, and I've been listening very closely, and I'm trying to think of what maybe I can do in collaboration with somebody else to support those turbines. And I just did a little bit of quick math, but if you get 8,000 wind systems out of one type, now look at, most of my customers can't afford an 85 kW or even a 25 kW. I mean, I dare say how many people are on this this webinar or this Zoom call, other than maybe Mike Berge, who's an owner of a sizable wind system, that could afford something in the 25 or 50 K range. And the SkyStream is very small, 3.7. It's really a 2.4 kW wind system. But when you look at 8,000 units out in the field at maybe a cost of 100 or 15,000 to 20,000, you're talking $150 million impact. And those systems are in the field right now, and they need some kind of support. I've done what I can do. I've had Jay Yeager help me, some other different people, even people from NREL. I just wonder if there's anything here that maybe we should be looking at.
Well, I think that's a great question, Kevin. And that's certainly an area that needs some attention as far as turbines that are out in the field that no longer have the manufacturer active to supply parts. That's certainly an area that there may be an opportunity in CIP or outside CIP for, proposing ways of manufacturing those parts that are needed for turbines that are out there that aren't currently available. So, I certainly would like to see those turbines that are out there being maintained and finding ways that we can help support them to stay active and be useful assets.
Okay, thank you.
Yeah, I would agree with that. I think on some level, it's a really hard question because in the case, as you know, Kevin, I'm sure that the IP exists somewhere. So a company owns it. I don't know what it is, but someone owns it. And so
What do you know by chance, sir, what NREL may own?
So that's a huge legal question that no one has tried to get into. So I think there is this question about if push came to shove, could an organization like NREL, because we did fund some of the work, take control over that IP. Again, you'd probably end up in with lawyers arguing that for a decade. So I think there's a couple approaches. Sonsite, their approach certainly is we're building a turbine that can go on top of a SkyStream tower. Okay, and so we'll just replace the whole thing, and they have defined that as a market space for them, and their turbine is designed to be able to do that. I do think this kind of question about manufacturing, is there a way to get around the IP or something and manufacture parts that would fit on a SkyStream, even if they were not the original SkyStream parts or something? I think that would be perfectly viable, and I think you could make an argument that your market out there is the 10,000 SkyStream units that are out and about someplace, and the parts are getting harder to come by. So some sort of manufacturing, or maybe even a component improvement to improve what was on there, the new board. And maybe this is something that Brent would have more experience talking about, because he's played with the SkyStreams more actively than I have. But I think there are things that you could propose there. The idea, again, looking at CIP, you'd be tying it to a product. You don't necessarily need to own the product. And in this case, it's pretty clear to everyone in the industry that no one really owns it, but there's a fleet of 10,000 of them out there. And so proposing something for spare parts for those, redesigning or remanufacturing the board or something of that nature. You have a better sense of what's failing on them than I do. I think stuff of that nature wouldn't be out of line in regards to a CIP proposal, and the fact that no one is making the turbine right now is secondary, because you can demonstrate that market that exists for service.
Being as I have this audience, which is really amazing, a lot of the people from NREL and Department of Energy, I can't say enough good things about the SkyStream. I've got, in this county alone, I got 250 or so up. I think I may have 4 that aren't running. This piece of equipment is like no other, I believe, wind turbine made anywhere in the world. It's that good. And I stood here, we had a 90-some mile an hour wind come through our county. This happened maybe 3 or 4 years ago. Every wind system, and I'm not gonna go through what they were, in this county was destroyed. And the Department of Energy for the state of Wyoming called me up. And they said, we want to talk to you about what went on the other day. And because they had all these calls coming in, they were contributing money at the time as well. Every turbine in this county was destroyed, with the exception of probably at that time 200 SkyStreams that were up. I never even got a call for an antenna. Nothing. I mean, it's that good. And I know it was built in collaboration with NREL. I mean, it just tells me really how damn good our engineers, our scientists, this government collaboration really is. I mean, these turbines are amazing. And it is almost a crime to see these things abandoned in the field. It's really, really sad.
I would agree. I would agree. Are you at all part of the, so I know DWEA sees this as an issue, and there's the Orphan Turbine working
Yes.
group? Okay, so
Yeah.
you're familiar with that. That Trudy Forsyth leads for DWEA.
Yeah. And just a shout out to Mike Berge. I joined DWEA, so just to let you know. Didn't want to get beat up.
I'm sure he appreciates it if he can get himself off mute.
I
Okay.
appreciate it. Thank you.
Yeah, no, I don't think anybody would complain. And Dave, I mean, you work for SkyStream, so I don't think anybody would disagree to the fact that it was a great turbine, and the fact that the venture capital sunk it is a black mark on the industry.
Well, we're still supporting it.
Yeah.
So, you know, and we're making some parts that we can afford to make, but not everything's available to us.
Mhm.
Okay. Thank you, guys. Appreciate it.
Certainly.
Yeah,
Thank you for your comments. Go
Yeah,
ahead.
thanks,
David.
Kevin. Yeah, certainly. I used to work at Southwest Wind Power and help to develop SkyStream. So a big part of my heart is in the SkyStream, and it really hurts to see that it's not being supported right now. And I would love to help turn that around any way possible. So, but yeah, certainly when IP gets wrapped up in some bank that owns it and doesn't do anything with it, which is possibly the case right now. I'm not certain of that, but it's be nice to be able to untangle that and be able to get meaningful support with the customers that are out there.
There is somebody who really does have that IP, and they're defending it because Rob Wills and Jay paid a company that had built some inverter cards and had never delivered them to take them so they'd be available for parts. And the people who own the IP found out about it and threatened to sue them. So they didn't get them. I don't know whether the company that owns the IP actually paid for them and got them, but so there is a company that's active in some way about it, and so Rob Wills would know how to contact them because they contacted him for sure.
Yeah, that's this, not to get into the deep too in the weeds, but then once they got it back, they, for lack of a better word, abandoned it. And I don't know what happened beyond that, other than the fact that it was sold to, I believe, HCI in Kansas. And I don't think they even know who, my understanding is they don't even know who owns the IP at this point.
Oh, God.
The one that pulled it back was the trustee, as my understanding. Or
Oh, okay. All
the
right.
bank or the bank or whoever that is. Yeah.